Okay, my name is Brigitte Burzy. I'm going to be presenting this webinar for you. I spent 25 years doing full life cycle production development, from individual contributor, team lead, architect, system engineer, and finally project manager. And I'm going to be covering this topic, REST for architects. Now, why is it called REST for architects? Well, we know architecture is all about the whats. What are the requirements? What are the components? What are the protocols we're using? What are the interfaces? Well, design is concerned with how to implement the architecture. So in the architecture, we're thinking about all these whats, preconditions, post-conditions, the interfaces. The interfaces are part of architecture. They're part of the what. What are the interfaces? What's the data going through them? And if your architecture specifies REST, then we have a very specific framework on how to nail down the other whats in our architecture. So the success of your RESTful services is going to lie on your architect's knowledge of this REST framework. And that's what we're going to be going through. So what are we going to cover? First, we're going to level set everyone on what REST is briefly, and the REST principles. And the principles with the maturity model let you know if you're really applying REST in the right way. In REST, everything is a resource, so we're going to have to talk about those, and also the CRUD verbs. These are the verbs that you use for every single request that you make. We're going to compare REST against SOAP. There's times when you want to use either one, so we have to understand SOAP some, and then how to learn more after this. If you have questions, go ahead and type them in the question. If I see them, I'll answer them now. If I'm on a roll and I miss them, I'll hit them at the end, okay? So, REST stands for Representational State Transfer. Okay. The thing that's important to know is it's not a software architecture. Okay, an architecture is the abstraction of the components and the connectors and the data and the specific system or application you have. There's different aspects of the system that have their own architecture. You have a network architecture, a security architecture, the architecture of the software itself. But REST is an architectural style. The style is more about the constraints around the architectural roles and features and elements. Okay, it can be applied to many different architectures, and an architecture itself can have many styles applied to it. So REST is an architectural style, and it is based on the architecture of the web, which makes it very easy to understand. It embraces the architecture of the web in itself and the rules it has. Now, REST was introduced by Roy Fleming in his PhD dissertation. And it's not surprising that REST is so enmeshed with the web, because Roy Fleming is the author of HTTP itself. And to give you an idea of what the whole idea of REST is, Martin Fowler, one of my great heroes, when he was working on a review for the book REST in Practice, he said that the book's heart itself was the notion that the web is an existent proof of a massively scalable distributed system. And it works really well. I mean, we're not really good at doing distributed systems that are massive that work this well. And so we can take ideas from that to build integrated systems more easily, which is what we're doing with REST. So, since we have to understand REST as an architectural style, the architecture of the web is really important to understand. Luckily, it's not hard. We have our URIs, our universal resource identifiers. When you're thinking of the web, you're probably thinking of URL, which is a resource, is a URI. The difference is the URL actually has to go to a location, because it's a universal resource location. But the identifier just has to be unique, so that anywhere in the universe we can identify something. We have our standard HTTP protocol, our puts, gets, deletes, and posts that we understand very well. And we have a different representation, lots of different representations we can use for the data that's flowing over the web. These are our MIME types. We're going to be concerned in this about the HTML, well, not HTML so much, but XML and JSON, which are a couple of the MIME types. So the architectural style that we place on top of this web architecture in REST is we're going to be dealing with resources, and they're going to be identified by one or more unique URIs. So you can always find a resource by its URI anywhere in the known universe. We're going to heavily leverage this HTTP protocol as our verbs, our actions on what we're doing. And we're going to represent the resources in either JSON or XML, probably JSON. Now, this was a lot of stuff about resources, right? Which isn't surprising because in REST, everything's a resource. So principles of REST. There are 4 principles that were in the dissertation. Another one has come on since then. Okay, the principles. First, we're going to have addressable resources. These resources are going to have a URI so we can address them, we can find them very easily. The resources can have multiple representations. So how we are going to send these resources around across the web in a message can be in multiple ways. We're not going to say we have to use this one representation. We can use multiple, whatever we want. We can send them over as a Word document or JSON or XML, whatever you want. We're going to have uniform operations. The same verbs are going to be used no matter what the resource or what we're doing. We're going to have a set of these uniform operations that are going to end up being HTTP. And the clients and the servers are going to communicate statelessly. So there is going to be no state. The last one is links. The web, you can say, was built on hyperlinks, right? Well, these links can be used to connect resources in different ways. So how do we know how well we're doing with these principles? Well, Richardson Maturity Model evaluates your application against these principles and tells you how you're doing. Okay, it was developed by Leonard Richardson, and Martin Fowler has in one of his blogs, The Glory of REST, he talks about this Richardson Maturity Model. And here's the different levels. You can actually be anywhere from level 0 to 3. If you're level 0, you're in the swamp of POX, the plain old XML. Level 1, you're starting to use resources. You get to level 2 when you start to use the verbs. And when you get to the hypermedia controls, you're actually to the glory of REST. So to give you an idea real briefly on how this works, we're going to go quickly through these, the diagrams on the different levels here. If you just go ahead and Google Richardson Maturity Model, this will come up right at the top if you wanted to read it later. So here's level 0. This is how most people start out. You have, this is your client, the purple, and here's your server, and it has one URL that you're going to. And you're using XML in your message. You're doing everything as a post. You're using XML. The server needs to be able to parse that to figure out what to do. It's going to send up some XML back as a request. The client has to parse it. You have some very tight coupling going on here. These are developed together. There's only one place here, and the parsing's here to figure out which component has to do what. So that's your swamp of POX, okay? If you go to level 1, you're going to start using your resources. That means you separate on the server different URLs for different resources, okay? So in this, we're actually creating, I should have told you this, we're trying to do an appointment. So the first post is looking for open slots, appointment slots, which you get back, and then the next post is actually saying, this is the appointment I want, and you get the appointment back. So with using resources, instead of everything going to just one URL, and then it having to figure it out, now we have 2 URLs. We have a separation of concerns going on here. You have one URL you go to, which says, okay, give me the slots, and then the other one that's responsible for actually making the appointment and giving you your appointment back. But we're still just using XML. we still have this tight coupling going on because no one else is going to understand these messages unless they were developed together. So then you get to the next level where you actually start using verbs. And an interesting thing happens here. Okay, since we're using the well-known gets, post, get's going to get something back, post is going to try to create something on the server. These are actually specified. They have a specification. IETF, we're going to talk about that, has specified the HTTP protocol. And so this means something. If we do a get, the server knows what we're supposed to do, because that's exactly what we're going to do. And then we have our information. And then there is a well-defined set of responses that can come back on the HTTP that mean different things. So our get is going to get information. It's going to get all the open slots. Our post is going to try to create an appointment on the server, a resource, and that's going to come back to a one created, or it could have come back with a different response that would tell the client exactly what happened. Now we suddenly don't have as tight a coupling. Since HTTP is well known and its rules are well known, if you follow them, this client does not have to be developed with the server. The protocol is understood intuitively to begin with. There's some other things that they have to know about how to do the resource, we'll see, but you've gotten a lot less coupling going on and a lot less parsing. We've simplified. Now, the third level, you notice when you create something, a post, the 201 created has to give the location of whatever it is that was created. That's one of the rules. So this gave the location as slot 124 appointment. So if we said a get on that with this URI, we should get back the information about our appointment. And this said 200 OK, open slot list. But if you use links and you link resources together with a hyperlink, you can get to the glory of REST, which is this. Okay, we did the same get, but this time our OK open slots has a link on where to go to book the slot. We don't have to know anymore. And when we went ahead and asked for that slot, for that appointment, it came back to our one created and gave us the URI on how to find that resource again. So we suddenly don't need to know even, all we need to know is the original URI to go to. Other than that, the server tells us where to go to get to the next state. So this is what we're going to be talking about. Let me get that out of here. So let's talk about these principles. First of all, we have addressable resources, the URI. Okay. This is provided by the Internet Architecture. We know that. So every resource is going to have at least one unique URI. And it's going to be something like this. If we have order number 10,025, there. We have /orders /2025. Very like the URL that we're used to. URL comes, the first domain is going to say where in the universe you have to go to the server. And then from there, you will have different things within your slashes that take you further and further down till you come to exactly what you need. And that's doing the same thing here. We know what we have in order, and then here's the idea of it. You can also get sets of resources this way. Okay, all trains from Mumbai, I'm not going to say that right, to New Delhi on this date, okay? So we have trains. We want all the trains. We're going to say the destination, or where we're leaving, and the departure and the destination, and the date, and that will come back with a set of trains. Now this resource representation, we know from our second principle, can be multiple representations. In REST, it's either JSON or XML, and it's normally JSON. So why? JSON's a trifecta. With REST, JSON, and JavaScript, you got three things that work really well together. The reason is your REST clients are going to be JavaScript clients. This is the web. They're going to have JavaScript. The JavaScript native, they have objects in JavaScript, and the native representation for these JavaScript objects is JSON. And so JSON is a common REST resource representation because it allows the servers to work with Java objects, the clients get to work with JavaScript objects. You have these RPC engines in between that do the creating and parsing of messages for them. It becomes very natural. Also, JSON's a lot more concise than XML. XML is very chatty. It has all those elements and attributes and all this stuff in it, and it takes a lot of room. It takes a lot of bandwidth. It takes a lot of time to parse, to find information in it. JSON has the benefit of XML in that it's still very human readable. It's easy to see. It's easier to parse. It's easier to generate, and it doesn't take hardly any bandwidth to go across. So we're going to look at the format of JSON briefly because as I talk about the HTTP verbs, I'm going to be using examples in JSON, so I want you to be able to understand it. So very briefly, here's the syntax. In JSON, objects have these curly brackets around them. Objects have properties, right? So the properties are going to have a name that's going to be in quotes a string, a colon, and then the value. If you have more than one property, we're going to separate them with a comma. So here's an example down here. We have one object, you can see the curly brackets, and it has two properties. Order ID has property 1, is value 1. Order details has a value of an extra object, right? So order details is a nested object. It has two properties, property 1 and property 2, with value 1, value 2 separated by a comma. So very easy to read, very easy to understand. So now let's talk about the uniform operators, the verbs. From the IETF RFC 2616, that's the HTTP 1.1 specification, that's what we are using. Okay, we have HTTP verbs, post, get, put, and delete. These translate into our CRUD. Post for create, get for retrieve, put for update, and delete for delete, CRUD. Create, retrieve, update, and delete. Now, these are the verbs that we'll be using from the client to request to manipulate the resource, okay? And every response is going to be having a well-defined code and content, and you can look at the spec for the rules. Some of these status codes have different content than others. And there is a rich supply of these things. If you look at this URL, these are the status codes. The ones that are starred are the ones that are the top 10, or the top, whatever many, top 10. You're the one that you use the most. 200, everything's okay. You have content, 200 created. You have content in it before. It was okay, but we're not sending any content back. Okay, so you can use the top 10 that you used to and get a reasonable REST interface and response for your clients. But the interesting thing is there's such a rich supply of information that you can give back instead. Look at this one, because you can click on all these and they tell you, you know, what's in them. This 202 accepted. This is where you accepted the request on the server side, but you couldn't complete it. You queued it up, you're going to get to it later. Okay, say you needed to update the database and the database was down, or you couldn't get on a network, or maybe there's a business rule. You can say 202. That tells the client, I expect to do this request, but I can't do it right now. So I'll get to it when I can. We have all kinds of other like redirections here. Some things are not acceptable. We have authorization, payment required. You can put a rich supply of information here. You can even do silly things to mess up people on April Fool's Day, like say I'm a teapot for 18. This is an IETF April Fool's joke. So coming up with what you're going to return. This is your interface definition, right? So the gets, puts, posts, deletes, that's easy, but what are you going to return back? What are the different situations you can be in, and what's the return so the client knows what they need to do? This is not, it's a lot harder to do than just very quickly coming up with, okay, we'll do the regular, or maybe we'll use these codes, always say 200 if it's right, otherwise, 404, and not giving information to the client. Doing that willy-nilly, lots of times, if you're not architecting this ahead of time, the developer just comes up with what they think should be done. This is easy for the developer, but it's not easy for your clients to use your interface then. Making it easy for the client, for the users and content maintainers, this is what you're doing architecture for. It's harder to do, but that's why we need an architectural approach. Remember the Richardson maturity model and what we're trying to get to. So let's look at these verbs. The first one is get. Okay, it's going to retrieve one or more resources. So it's your retrieval. The thing about get, it has to be safe. It can do no harm or no changes on the server at all. It also has to be idempotent, which means I can do it as many times as I want, and it's going to get the same answer. So unless someone third party has updated whatever I'm getting, I'm going to get the same answer over and over again. This can have no effect on the server. Now, looking here at this, this is the HTTP request we would be sending. It's a get. It has your URI here. We're going to REST web, but the URI, once we get there, is going to be catalogs, products, 1029. So we're going to be going into catalogs, and in the catalog area, we're going to go into the products area, and in the products area, we're going to get the product with the ID 1029. We're saying from the client, we can accept JSON. This is an interesting thing about the multiple representations. Since we're using HTTP in our header, we can tell the server what different representations we can accept. And then the server can figure out which one they can use, send back and tell them in the header, the client, what they're using. So the representation is negotiable, and it's already built into the HTTP protocol for us. Okay, once we've done the get, the request, the response is going to come back from the server. And these are some of the returns you can get. Okay. And the body is going to have whatever resources requested in whatever format that we say we're going to send it in. Here, HTTP 200 is the response back. The content type is JSON. Content leaks there, and then we have an object that comes back in JSON, 3 fields, price, name, and code. And of course, these are the values. So this would be a typical GET request. You could have errors. You can have things that that would be very normal, would be 404, I can't find it, or 500 some internal server error. Now, I showed you all those other statuses that could come back. So you'd want to go through there if you had something else that came up that was more special that maybe the client would want to know and be able to react to. Maybe you'd be able to use those status returns as well. Okay, and then we have our post. Post is going to create a resource. It's, think of it as your insert. One of the rules in the spec says that post is not idempotent, so that if you would think if you were going to do a post and an insert, and then you did another post with the same thing because you didn't get a response back, you were going to be doing different things on that server for each post. You might think of it as each post is inserting something in a list. And so you might end up with 2 posts of the same information, end up with 2 entities, duplicate entities on that same list. Okay, the request is going include the object properties and values, but normally will not include the URI, the identifier. And this makes sense because our post is creating something. It's not on the server yet. There is no identifier yet. So we'd be doing, like down here, we say post, and we have our REST catalogs products, okay? That's our URI. And we're going to be posting, so we're trying to create something. We're saying it's in JSON, our body down here. And we have a price and a name, but we don't have the ID because we don't know what it is yet. It hasn't been inserted. And the server is normally choosing the resource URI. Now, the kind of a twist to post is that it can also, if the resource isn't there, it can, if the resource is already there, it could update it. Normally when that happens, it's you have some kind of natural URI, like a social security number or something like that, so it's actually included, and it could actually update a resource that's over there. Now once you have done a post to the server is going to give you back a response. These are the normal success, 201. We created it here. This is normal, and it's going to give you back a body that gives you the URI on where to find that thing. Okay, we created something. I'm going to want to find it because I created it. So this is what I would be using on a Git to actually find the URI that was created. Okay. If you have a creation of a resource that can be identified by a URI you already know about, you might do a 200 OK or 204 no content. Don't have to give you back the URI to get to it. A 202 accepted, but I didn't get to process it yet, so it hadn't been created. This is kind of different because you're going to have to go and do a get later to see if it got created or not, because you don't want to do another post because you might create two of them, right? Because it's not idempotent. Okay, error, bad request, 401 unauthorized. Maybe you're not allowed to do that. 500 internal server error. Okay, put. Put is your update. So we have our insert and our get. Now we have our update. But the thing that's interesting about put is it's going to update the entire thing. So if you don't give every single property, whichever properties you don't give, the server is going to interpret that as, well, now it's a null or a 0, right? So here we have a put. There's the URI, catalog products 1029, JSON, and it's giving us value for every property. Now, put is idempotent, which means I can send that put as many times as I want, and it's never going to have another effect other than it did originally. And that makes sense if it's an update. But there's a little twist because the client here, the resource, if it doesn't exist, put can actually create that resource. But the client will be choosing the URI because it has to give every single value. So once you do your put, you're going to get something back from the server. Common things would be 204, no content. If it just got updated, you don't have, the server doesn't have to send anything back except, yes, I updated it. Or 2, accepted it but not yet processed. Now, if it was a situation where there was not that resource over there yet, and so this put is actually trying to create something, whether it knows it or not, you have 2 possible status you can give back. If it's okay to create it, if it doesn't exist, give a 201, created. And then on the 201, you would give back the URI of where to find it. If you're not allowed to create it, you'd probably go 404. 404 says, I can't find it. You're trying to update something that's not there. And the server says, and you can't create it either, sorry. So you get a 404 back. 409 sometimes comes back with a put. This says conflict. The request couldn't be completed because of the current state of the resource, wouldn't allow it. It could be a versioning conflict. Maybe a third party was trying to update at the same time, something like that. When you do a 409 with a conflict, you should give the client some information back that gives them some idea of what they're supposed to do. Are they supposed to retry? Are they not allowed to, or something like that? So they know what the source of the conflict is. Okay, patch. Patch is fairly new. Patch is like a put, except you don't have to supply everything. Whatever you supply, that's what's going to be updated, and everything else is going to be left the same. Okay? Patch, like put, needs to be idempotent. And just like all the others, the URI path is going to be in here. That's the resource that we're dealing with. So here we have, we're only going to give price. We're not going to give anything else other than information. This URI identifies which product we are going to update the price on. There's a question. Idempotency only applies when the request succeeds. Idempotency depends, you just think of it always. I mean, if you get an error back, of course the server's not doing anything. So idempotent, yes, you can think of it as it only applies when the request just succeeds, but it just think of it all the time. Puts are never idempotent. Gets always are idempotent. In fact, everything else is idempotent except put, which is the big important thing. I got another one here. I'm having problems seeing those questions. How will you get the URI later on a 202? That's something that you're going to have to architect, isn't it? Maybe if you had a 202, and this is what we're talking about if you did a post and it gave you a 202, so it says, I got it, I'm going to do it later. Well, you know all the relevant information. Maybe you'll have a get that you can get from, I don't know, the price, the product, whatever that is. You could do some kind of information that would be like an SQL get rather than having the exact URI. Okay, got another question. Are there design principles for REST services which don't deal with resources? For instance, monitoring something on a get, post, get has no payload, post has no payload. When you're monitoring something, whatever you're monitoring is a resource, and you're going to be getting information back from it. If you're not dealing with some resource, I mean, there's really any message can be thought of as some resource, whether you're telling someone something, a resource something, or you're getting a status back. There's always going to be a resource involved. Get would, if you were, what are the design principles for REST services which don't deal with resources? For instance, monitoring something on a get post. If you're monitoring something, you would be getting a status back, right? And so you would do a get for that status, and you would be getting some information back. A post would be creating something, and so that's not really a monitoring type thing. I hope that, if that didn't answer your question, go ahead and answer another one. Ask another one, okay? Okay, so that's patch. So we talked about put and post. Both can create an update. Post creates a resource, but it can also update an existing resource if it's already there. Put updates the entire resource, but if the resource isn't there, it can create it. So what do you do with this? The spec itself, RFC 2616, tells us that the fundamental difference between post and put is reflected in the different meaning of the actual URI in the request. So if you do a post, that URI identifies the resource that's going to handle the enclosed resource, the enclosed entity. So you have all this information about a resource you want to create, but the URI you're going to is going to be whatever process is over there that's actually going to create it. If you're doing a put, there is a resource that you want to update, and that resource, the URI, identifies that actual resource itself. Whatever resource is enclosed in a request that needs to get updated, that's the URI. So that's a fundamental difference from the spec. There's some others. Where's the URI determined? Okay, on post, since it's going to a process that's going to create that resource and send you back the URI of the resource itself, the post doesn't normally, client doesn't give the URI because they don't know it yet. So the server is going to supply the URI. And the only difference is, say, it's a natural key, like I said, social security number or something like that. That's a natural key. In that case, the post would be sending the URI over. And then that's the case when they would be able to update. On the put, the request always supplies the resource URI because it has to identify the resource that it wants to update. Also, this is very important, idempotency. Post is not idempotent. It is always going to do a change on the server. If it's doing an update, it's going to be seen as if it deleted what was there and recreated it. Well, put is always idempotent. Okay, we have a follow-up there to the last question. If we need to pass a JSON payload to a resource that we are monitoring, we can't do that on a GET. So what verb should we use if not post? Well, I guess if you're monitoring a resource, you're just going to be getting what you need from that resource. You don't need on the GET to give a JSON payload if you're just getting monitored information. Post is going to create the resource, and there's a resource there that you're monitoring. So post would not be the one to use. I'll tell you what, let me find you in here. I can unmute you, and you can ask, because apparently you have something that I'm not getting here. Let's see, where are you at? There you are. Okay, you're unmuted.
Yeah, hi. So we have a requirement for monitoring a bunch of resources. Like you said, obviously everything is a resource. So we need to send a set of parameters for that call, like an ID or some description that goes on to that monitoring call. So it can be done on a GET, right? So.
Well, yeah, your URI would be telling you exactly what you're monitoring, right? Because
yes.
you would be putting all the different legs all the way different down to whatever you're monitoring, and then the ID of it on your GET, and then you would get information back. But all the information you would need to monitor that would be on the URI. There's also, I'm not covering it here, but you can also do query parameters on the URI. So you can give extra parameters on the URI itself.
Okay, so pretty much the design principle here is just do everything with a GET and don't rely on a JSON payload, kind of high-level design principle there.
Yes, that's exactly right. Bingo. All the information you need about what you're trying to do can be in the URI and on the verb. The only thing that really comes back and forth in the payload is the resource when it needs to go. The information about the resource itself. Everything's a resource.
Great. Yeah. Thank you so much.
Sure. Mute you again. Let's go on. Okay. The last verb we have is delete. Delete's super easy. because there's no payload at all. All we have to do is say delete and give the URI. Delete's going to be idempotent because once you've deleted, you can try to delete as many times as you want, and it's not going to change the server. You might get a different return code back, like a 404 not found, but that's it. And here we have the different success statuses. 204 no content, 202 I didn't get to delete it yet, but I'm going to do it as soon as I get a chance. 200 if you have some kind of status about the delete you have to send back. 204 has no content. Of course, 404 I didn't find it, and our normal error requests. There we have it. So benefits of REST. It simplifies everything. Everything. Servers don't need to maintain state. This lets them be massively scalable. You can get all kinds of servers together and clustering, caching, pooling. You can do all this stuff because you don't have to worry about syncing state between the different servers in a cluster or the different thread pools. Every single request stands on its own, doesn't depend on anything else. You deal with it, you send it back, you're done. You don't have to have any kind of understanding of what clients you've serviced before or after. This minimizes coupling immensely, which enables evolution. The URI hides all the implementation details. REST is based on something we know really well, the web architecture. We know the familiar URI structure from using URLs so much. We know all the HTML verbs and status codes that can be mapped to CRUD, as long as we know how to map them correctly and how to use the status codes correctly. We can come up with very understandable, very explicit interfaces without having to invent any of it ourselves. Oh, I got a bunch of questions. Let's see. Yes, state is specific to the client. The server doesn't know about state. That is correct. So when you're talking about a stateless application, you're normally talking about the server. The client always knows its own state. But the server doesn't have to maintain anything about the client. Another question, I suppose the payload could be a JSON with complicated set of attributes to get about the resource. In that case, you would be using query for a get like that. You would probably want query parameters on the URI. If you needed something complicated enough that you needed a JSON object to explain it, you probably want to break up your interface some more. Remember, if you have different, the separation of concerns, if you have different locations for each of your resources, then you don't have to put it in the application, into the body itself. If you're trying to put all those things in the body, you probably need to break your resources up into different URIs so that it will go to different places on your server. If we need to pass a JSON payload to a resource that we are monitoring, we can't do that on a GET, so what for? Okay, I already answered that one. All right. No, when application, map to CRUD. Okay, benefits of REST. Yes, familiar. Great stuff. REST embraces the web itself, its architecture, and the benefits and all by just applying its architectural style on top of it. And we have a variety of data formats that we can use. Okay, we've been using JSON because it just gives native support to our browser client, and it's less bandwidth than XML, and it's wonderful. But we could use XML. We could use any format you wanted. We could use, like I said, a Word doc. You could use a PDF document. You could use your own, however you want to do it. REST doesn't care. You can use any data format you want, which gives you a lot of flexibility if you already have some representation of your data that you're using and you don't want to parse it and manipulate it and marshal it into and out of a different format like JSON. You don't have to. Okay, SOAP. Everyone thinks of services, web services as SOAP because it the granddaddy. It was the first thing. And so let's talk a little bit about SOAP and compare it with REST. It's mature. It's been around since 1998. It was invented by Microsoft to solve how to send objects and deal with things in an enterprise type setting. So it's very enterprise oriented, okay? Everything is XML. XML was the super cool thing way back then. It was going to solve everyone's problems, and so it dictates that your message must be XML. It's going to have a SOAP envelope and a SOAP body. And the SOAP body is going to tell you what you need to do, okay? All the information, like I've been answering these questions, but we have to have the things in the body, not in REST. In SOAP, you did, because everything's a post. And then you can have optional header and fault sections if you want in here. This is all XML. SOAP is stateful. If you're in the enterprise, you need to know, who someone is, if they're authenticated, what they're authorized to do, where they are in some application. Things are stateful. You can write SOAP so it's not stateful, but you'd better go to REST if you do that. SOAP's pretty heavyweight. There are a lot of these standard extensions from the World Wide Web Consortium that let you do a lot of things that you would need to do in an enterprise. Security, automatic transactions for transactions, doing atomic transactions. Since it's stateful, how do you reconnect to a client when they've been disconnected from you, things like that. Now, SOAP can transport over any protocol, which is different from REST. REST needs HTTP. SOAP, you can use it internally. So you can use it internally using JMS or anything else you want. And it focuses on the web service interface itself. While REST focuses on resources, it has an interface that specifies what you're doing. So for every message, you would have a WSDL, something written in the web service definition language that explained what this message had in it, how it was used, post conditions, preconditions, all the information you would need, a client would need to be able to use this message. And so that's how it gets clients to be able to use web services it doesn't know about, was not developed with. The client can get the WSDL from that web service interface and know how to use the web service from it. Okay, SOAP puts the verb inside the message itself, which is XML. So everything's a post, okay? Everything's going to be a post. Here's our post, and here's our body. Here we have an envelope, okay, because we have to have that. And nothing's really in the header here. And then we have our body get order. And so that get order tells us that we're doing a get. We're doing a retrieval. If we did a create, update, or delete, this body would be different. So you have to go and parse the XML to find out what the message is that you need and what to do with it. This is pretty much at level 0 of the swamp of POX with the Richardson maturity model, if you were doing this with REST. Because everything is a post, you're not using your verbs, and you're putting what you need to do inside the body itself. But a lot of places use this. So let's compare these things a little. SOAP is very enterprise infrastructure oriented, gives you ways to do transactions, gives you ways to do security, gives you ways to do all kinds of things. There's lots of extensions for SOAP to be able to do enterprise type, massive applications like we're used to seeing inside our enterprises. REST, very lightweight. It's designed around the web rules. It's all about uniform CRUD interfaces and verbs, all about the resource, light, agile. REST is more appropriate for, well, we'll wait to the next one. It's communicating Let's go through the stateful first. That'd be easier to explain then. SOAP is stateful. You've got to maintain an open connection, which is normally used with stateful APIs. If the request and the response is interrupted, it's complex to retry and reconnect. There's a lot of overhead with that to reconnect that client and get their session back so they can get their state. It's very good for things like financial payments, telecommunication services, the kind of things out there that are using SOAP include PayPal, Salesforce, things like that. REST is stateless. So losing a connection isn't a problem. What makes it excellent for something that is a mobile application that you're constantly going from one tower to the next, and you're constantly disconnecting and reconnecting with your cell phones. Okay? It's easy to retry once the cell service is back. It's not going to do a retry for you. You're going to have to deal with that yourself. It's great for social media, social networks, chats, mobile services. The companies that use a lot of REST, you have Twitter, LinkedIn, Slack, so forth. Another difference, SOAP is all about the interface. What are we trying to do? Okay, the interface is going to do something. And every application is going to have unique messages, unique verbs, unique ways of doing things. It's very flexible, and so everyone does things the way they want. On REST, because you get to define it in the WSDL. REST, the focus is all about the resource, which is identified with the URI. You got to have that URI in your request to say what resource you're dealing with, and you need to have one of the HTTP methods as your verbs. So every application is going to use the same verbs and the same message structure. Okay, we got a question. Are there best practices for granularity of the data in REST, request response, view-based, page form, element, model, entity-based? Taras, that would depend on your application. It's one of my favorite answers, it depends, because something like that would definitely depend. There are best practices, and I'm going to be showing you at the end our REST. We have a one-day REST for Architects class, and we actually get into some of those. When I go through the outline, you'll be able to see where some of that would be. It's way out of scope for a one-hour webinar, which I'm almost out of time. But great question. Yes, there are best practices. Depends on your application, and so the course tells you some different ways to look at that. So when do you use REST and when do you use SOAP? Like we said, SOAP has some very big things. Salesforce, PayPal, DocuSign, they all use SOAP. But you can use the same outcome with either protocol. So what do you want to do? Well, first thing you want to do is try REST. SOAP's been around a long time. It's mature. It's been dominant. But REST is winning out. It's got over 70% of the public APIs now are using REST. They all must know something. All the cool kids are doing it. It's faster, easier to understand, uses less bandwidth. It's becoming the de facto choice, REST and JSON. Now, when would you use SOAP? If you need extra security concerns, REST is going to give you the point-to-point that SSL gives you. But if you need extra privacy, integrity, all those other security concerns to be addressed, you probably want to use something like SOAP. If you need transactions that are built in, if you need to be able to have retry data to reconnect for you, if you need to deal with state, okay? If you need a formal contract, this is important if you're saying you're doing a B2B with some other entity that isn't your company, and you need some formal contract between them, the WSDL is that formal contract. It's enforced by it, which helps you. Another question. No, that's the one I just answered. The best practice for granularity of data. I already answered that one. I thought I got rid of that, sorry. So, where to find more information? If you go to the WebAge Solutions website, who's giving this, and up here in the search, say REST for Architects, you'll come up with a search, and you'll be the first two up there. They both go to the same place. And this is our one-day course, Designing REST Services for Architects. It's a full day, so when you show up, be sure that you've had your coffee already. It's going to come out with an overview of REST versus SOAP. A lot of what I did, I pulled from all over, so it isn't, there's a lot more in here than what I covered. They're going to give you more on JSON, especially JSON schemas. If you're going to have the object go back as JSON, with XML you can have a schema that is enforced that knows that you're doing the right things. You're not putting a string in a price, say. You're putting the number, that kind of thing. And we have JSON schemas, so it talks about that. Because if you're doing the interface and using JSON as an object, you got to come up with a schema, right? Security for REST. This is a big section. There's a lot of stuff in here, web tokens, OAuth, things like that, the JWT. Then we have a lot, the afternoon's about designing these best practices. How do you go about designing a RESTful service? What's the formal specification look like? That kind of thing. And the canonical data model. The same data model, the server and the client are going to have different data models that they're using, but you need to have probably one that they all translate to. This was done a lot in Corba when you had a lot of homogeneous systems, or heterogeneous, I guess it is, different systems with different representations. Then you do, this is a really good section, the soft considerations, the fallacies of distributed computing, and things that you can mess you up, like the bandwidth is not infinite, latency is not zero, and then the whole thing about usability and extensibility. If you don't design these correctly, you really want these services to last a long time, and you're going to have to extend them. So different ways and different strategies that you can come up with how you're going to extend them in the future. And then remember I said that using these status codes correctly gives the client, makes the life easy for your client, makes it usable. But there are certain things you can do where you go too far for the client. So where's the balance? And this talks about how to do the interfaces so it's a good balance between what is good for the server and the client as well. Bulk operations, large queries, how do you handle those? And then we go to some tools. If you're going to be defining these interfaces at the architectural stage, you don't want to be in the code, right? You're going to be at a higher level, and Swagger will let you define your tool, define your interface to, you know, the JSON specification all the way down to there. And when you get it done the way you want it to be, it's a really nice visual tool. It will also create your documentation for you and will create your stubs that development can use. So Swagger's a nice tool. Manually test, we talk about the different things like curl that you could use, different tools, but then we concentrate on Postman, which is a GUI tool that you can use to manually test a web service. There are exercises. Like I said, it's a full day. So you would get hold of someone in WebAge Solutions, your contact, if you wanted to do this class. There we go, and that is it. Any questions? I know we've been asking some good questions, but if you have any other ones now. Okay, Tom has his hand up. I'm just going to unmute you. How about that? Go ahead, Tom.
Oh, was that me? Sorry, I might have accidentally touched the button there. Beg your pardon. Sorry.
Okay, mute you back up. Okay, well, if that's it, this will be available. I'm recording it, so it will be available later on, and you'll get you'll be able to get not only the PowerPoints, which I just updated, so I got to send them up, then they'll be available for you, and also the recording later on. So thanks for your attention. Thanks for all the great questions, and have fun with the rest.